When I was a kid, one engineering mystery always fascinated me. How can machines like hydraulic scissor lifts and dump trucks generate such enormous force? A scissor lift can raise several tons of material high into the air with ease. Many people assume the engine is doing all the heavy lifting, but that's not actually true. So where does all that incredible power come from? Today, we're going to uncover the answer. And it all begins with the most important system inside modern construction equipment, the hydraulic system. Let's start with one of the key components of any hydraulic system, the hydraulic cylinder. This is the device that converts hydraulic energy into powerful mechanical force. To understand how it works, we need to revisit the principle that we learned in physics class, Pascal's law. Pascal's law states that pressure applied to a confined liquid is transmitted equally in every direction. But the really important part is this. The same pressure acting on a larger area produces a larger force. The relationship is simple. Force equals pressure multiplied by area. F equals P times A. Imagine two connected pistons. If pressure is applied to the smaller piston, that same pressure is transmitted through the fluid to the larger piston. Now, if the larger piston has 10 times the area of the smaller one, the force it produces will be 10 times greater. This is the fundamental principle behind hydraulic force multiplication. A hydraulic cylinder takes advantage of this principle. Inside the cylinder is a large piston. When high-pressure hydraulic oil enters the chamber, that pressure acts across the entire surface area of the piston. Because the piston area is large, the resulting force becomes enormous. What starts as hydraulic pressure can quickly be transformed into tens of tons of lifting force. That's why a relatively compact hydraulic cylinder can move massive loads with ease. But here's something important. The hydraulic cylinder does not create pressure. It only converts pressure into force. The component that actually generates hydraulic pressure is the hydraulic pump. So how does a hydraulic pump create that pressure in the first place? Although there are many different designs, they all operate on the same basic idea. They squeeze the fluid. The only difference is how they do the squeezing. In engineering, three pump designs are used most often: gear pumps, vane pumps, and piston pumps. Let's take a closer look at each one. The gear pump is probably the easiest to understand. Two gears rotate inside a sealed housing. As the gear teeth separate on one side, they create expanding spaces that draw oil into the pump. As the gears mesh together on the opposite side, those spaces shrink and force the oil out under pressure. This continuous process produces a steady flow of high-pressure hydraulic fluid. Next is the vane pump. Imagine a rotor spinning inside an off-center housing. Around the rotor are several sliding vanes. As the rotor turns, the spaces between the vanes continuously expand and contract. When the spaces expand, oil is drawn in. When they contract, the oil is compressed and pushed out. The result is a smooth and continuous pressure output. Finally, we have the piston pump. This is generally the most powerful and efficient hydraulic pump design. You can think of it as a group of high-speed syringes working together. Multiple pistons move back and forth inside a cylinder block. As a piston retracts, it draws in hydraulic oil. As it moves forward, it compresses and pressurizes the oil. By changing the angle of the swash plate, engineers can precisely control the pump's output flow. Because of their high pressure capability, efficiency, and controllability, piston pumps are commonly used as the main hydraulic pumps in excavators and other heavy machinery. So the real muscle behind construction equipment isn't the steel structure you can see. It's the hydraulic system hidden inside. The pump generates pressure, the hydraulic fluid carries that pressure, and the hydraulic cylinder transforms that pressure into the tremendous force that powers some of the strongest machines on Earth. Once you understand hydraulics, machines like scissor lifts, dump trucks, excavators, and cranes suddenly become much less mysterious and much more impressive.